I can try and make it like 0.8. I want to make sure this isn't some like transform problem, some scaling issue from the matrix, the GL matrix stuffs with the size. So I set it to twice the size, which is a lot bigger than twice the size. But yeah, it looks like it's working, because if I hold it up correctly, oh no no no, oh, and there's this guy. Oh no no no. Oh no, he's gonna mess everything up. Okay. Well, actually, yeah, if you look, it's a little bit bigger. I don't know if you can see using that camera. Yeah, it's not really easy to see. But the effect box is slightly bigger than the line, but it doesn't collide with anything. So we can take care of that now. And then we'll be able to get sound again. So what was that? Well, I want to eat. Let me just quickly steal the relevant function from snakeable entity. Yeah, there's hard test collides with entity and also test collides with entity. So the test collides with entity just looks at the immediate XYZ bounding box. Since we are using rectangles and squares only, so far that's been exactly what we want. But for example, the shooter object, I think, might redefine this, the hard test. And for snakeable entity, we're doing something weird. We needed to check yeah, I'm going to put that down here. Sorry. Yeah, for snakeable entity, we need to check if they were snakeable entities or not. For this class, we don't need to do that. This is an immobile class. And all we want to check is the other class, well, yeah, we can just use the other class as a yeah, I think we can just use a snakeable entity code, this function down here. So this splits up the treatment into two different things. But you see what we're doing here is actually what we can just do up above. Let me just see how they do it just to make sure. No. The reason snakeable entity was complicated because it has to look at its subchildren versus the other guy's subchildren. In our belts, we are going to fully contain the subchildren, so we don't have to do stuff like that. I think hard test collides with snakeable entity and hard test collides with, so we want normal physics entity because we aren't expecting walls to these belts to collide with other belts anyway. So I'm putting that here and deleting this stuff. So we don't have children anymore. That will make us redo this loop into a for loop probably. So entity A is us, and then so once we've checked us, this is a different thing. Yeah. This is what we do. I got it. Alright, I'm gonna keep that down there just in case. But so we are entity A, the other guy's entity B, and we'll pass that in, right? Well, other's the other guy. So we don't need all this stuff probably, but anyway, we'll just hold it for now. Yeah, it looks like we transfer it into cube so we can use some math library, our own math library, our geometry functions. So we just do a size t I for I equals 0, I less than mn t t is dot size I plus plus. Then we want to iterate over each guy. We don't care about, this is the cool thing, we don't care about our own, we don't care about the belt. We can allow objects to pass between the spaces. So the only thing we have to check are the spaces, and that's not the spaces but the entities within. So we just do a hard test collides with entity for those guys. We can do the filter overlap directly, but I think a hard test, we can't do hard test with those guys. This sucks. Yeah, well, we can just do this. So I'll say entity A equals, and these aren't snakeable entities anymore. These are now, no, yeah, these are now normal physics entity, or are they filter entities? They should be normal physics entity. And if I have the add, yeah, there was going to be some point where I had to upgrade the filter entity to normal physics entity. Yeah, and that point is now no biggie. No, this is totally fine. There's only one place we're using it, so especially easy stuff. Yeah, so now when we're doing this test, we have size, because we do this. And then we just get the size like this. We have the other guy's size and pos. So this is a cube. And we have this lovely cube detection, cube overlap detection, which is a nice function. It's only probably 3 lines of code. And then return no, otherwise. And that's all. That's all there is to it. Yeah, so this will detect the collision on the children, and we can test it by running. This won't do the collision effect where there's a sound that comes out. Let me fix these. Undeclared identifier children. Yeah, okay, so there's children. So we don't need that. Yeah. Let's try build that again. Build failed. Filter entity does not have a member size. Is that right? Wait a minute, how did they do that? They just did a... yeah. That's tricky, huh? Well, we can just do normal physics entity. We can just do this. Yeah? What do you think? Because we know they're... oh, we don't know the other guy. We don't know that the other guy is a normal physics entity. Okay. So we can make it... we can test this. And we do this implicitly above. Well, explicitly above. So here we just decide only to do this test for a normal physics entity, and that's fine. So let's try build that. That might fail. I wouldn't be surprised. That failed. Parse issue, there is a V because of my Emacs twitchiness. And that is in 164. GG. Alright. Well, we don't need that one. So let's try building again and running. Might build, it built. So what do we got now? Now we're expecting collision only to happen with the effect box in the middle. Stuff that goes around should not hit it. I have to move this guy out of the way though. Oh no, now he collided with it. Okay. I accidentally hit the sign, the tap sign thing. Well, it looks like they're still interacting. They're still colliding with the wall. And they're not colliding with the box. So it's not working. Why? Well, this is a good point to eat. So I'm going to kill the stream. Yeah. And well, hard to say if the stream is going to exit. I have to wait another 40 seconds. I'm still working out these scripts for the YouTube upload. Okay, I was doing the wrong thing.